During today's laboratory, we're going to conduct a uniaxial compressive strength test experiment. So in this experiment, we're going to use a cylindrical rock sample. So we're going to start this experiment from measuring the dimensions of this sample, such as diameter. So first I'm going to measure the diameter of this sample. We're going to make 3 measurements starting from the top of the sample. So the first measurement is 69.92 millimeters. Then I'm going to go to the middle of the sample. I'm going to rotate the sample by 1/3 of full rotation, 69.84 millimeters. And then I'm going to go to the bottom and I'm going to again rotate the sample. I have 69.84 millimeters. So we're going to extract the average, just for this sample. Sometimes the reason, is why I took 3 measurements. Sometimes if you look, just at, those drill core samples, you're going to notice, slight variation in the diameter, of the sample. So we want to make sure, that we extract, average diameter from our measurements. We're also going to measure the height of the sample or length of the sample. In this case, its first measurement is going to be 140.51 millimeters. We're going to rotate this sample 140.66 millimeters, and we're going to rotate the sample again 140.69 millimeters. So this is this measurement ensures us, that we have, perfectly parallel 2 ends of the sample. Now, the next thing which we're going to do is we're going to place this sample in a device here, which we're going to use later on to measure the deformations of the sample. So in this particular case, we're going to use device which is using 2 LVDTs. So LVDTs stand for linear variable differential transformers. So in this case, we're going to measure vertical deformation and horizontal deformation during the test. So after each experiment, we examine how the sample failed. So in this particular case, we're going to pull out the sample from the LVDT's jacket. Or we're going to try at least pull out, just what's left from the sample. And we're going to look, just at the modes of failure. So I'm looking here, just if I see there's vertical fractures. So this thing gives me indication, just that the sample failed in tension. But also we're looking, just for this cone here, conical shape, just which tells us, just that there was also, just a shear type of failure occurring during the experiment. Okay. So we can see, just that the sample completely failed. So we have fractures, just going through the whole length, just of the sample, and we were able to record the maximum load during the failure, and we also were able to record using, just those LVDTs, horizontal and vertical deformations during the test. So having this information, we'll be able to calculate things like Young modulus and Poisson ratio for this particular sample.